one function we can determine from by algebraically methods for one-to-one function. If A is not equal to B, then FA is not equal to FB. If FA equal to FB, then A must be equal to B. This is in the range. This is in the domain. So we test for one function whether that function is one-to-one or not one-to-one. Let's say for functions of fx, which is equal to x plus 1 over x plus 2. Show algebraically that the function fx is 1-to-1. So we have to show whether this function is one-to-one function. So we test. We substitute x with either A or we substitute with x1. We want to show the difference. So let's say we can say that to A plus B, A plus 2, we want to show that to B plus 1 they equal to B plus 2. Multiplications cross multiplications to A plus B multiplied by B plus 2 so multiply. You get 2AB plus 4A plus B square plus 2B equal to 2AB plus A plus 2AB plus 2. Is that 2A plus 1? Plus B. Oh, plus 1 here, sorry. Plus 1 here. 2AB plus 2AB plus 4A plus B. plus 2b. 2ab plus a plus 4b. 4b plus 2. We multiply, cross multiplications. Then 2ab plus 4a plus b plus 2b minus 2ab minus a minus 4b minus 2 equal to 0. By bringing all those into left hand side. So 2ab and 2ab. So we have for a plus minus a3a. Okay, it's plus 2 only, right? 2ab plus 4a plus b plus 2. Sorry. 4a to 2b minus 3b plus 2 minus 2, 0. So it's equal to 0. For a minus a3, ab minus 4b minus 3b, so we get 3a equal to 3b, therefore a equal to b. So we show that it is one-to-one function. So we show algebraically, it is one-to-one function. So a is equal to b. Right? Then, let's say another function you want to determine. The function is one-to-one or not one-to-one. Let's say for the functions 2 minus 3 over 4 plus x, show algebraically that the function is one-to-one function. So when we substitute x with a, 2 minus 3 over 4 plus a, 2 minus 3 over 4 plus b, 2 minus 3 over 4 plus a, minus 2. We bring this 2 into left, equal to minus 3 over 4 plus b. So minus 3 over 4 plus a equal to minus 3 over 4 plus b. Right. Cross multiplication, we get minus 12 minus 3b equal to minus 12 minus 3a. So we say that 3b equal to 3a, or we say 3a equal to 3b, a equal to b. Same. We show that it is 1 to 1. So we can say that fx is the function of 1 to 1. 1 to 1 function. Fx is 1 to 1 function. Right. That's to determine of whether 1 to 1 function or not 1 to 1 functions. Because given one function, not necessary that that function is 1 to 1. We may test the function is 1 to 1 first, and then we say that it is 1 to 1. Otherwise, it's not 1 to 1. We have to test first. Look whether the function is 1 to 1 function or not 1 to 1 function. For one function, whether 1 to 1 function or not 1 to 1 function, this is the methods or the way how we want to prove the function is 1 to 1 or not 1 to 1. The methods that we use here is algebraically methods. We also have another methods which we call graphically methods of determining whether function is 1 to 1 or not 1 to 1. Graphically methods. Graphically methods to determine given function, the function is 1 to 1 or not, by use what we call horizontal line test. We use horizontal line test if the line intersect graph of function in at most one point, then we can say that the function is 1 to 1. Look, when we test, we look whether it intersect at the graph, intersect a line as more than 1 point. If more than 1 point, so we can say that the graph is not 1 to 1. If more than 1 point, supposed to be only always at 1 point. If more than 1 point, the graph is 1, not 1 to 1. That's graphically test of the function. As what we looked before is algebraically test. That's graphically test. We draw one line, one horizontal line, and we drag that line. Same like last time, we have vertical line test. Vertical line test used for what? Vertical line test. Remember that vertical line test. Before we have vertical line test. Vertical line test used for what? Please on your camera, right? Because not many are on their camera here. Vertical line test. Before vertical line, but now, today is horizontal line test. Horizontal line test. But before vertical line test, want to refresh you that for vertical line test. For what?
Function or not function?
Function or not function. And now we know that it is a function, but we want to know whether the function is 1 to 1 or not 1 full 1. We may use horizontal line test, one way of testing, apart from algebraically test that I showed before. Now, another test is horizontal line test, right? When we say the function is 1 to 1, so the function supposed to have an inverse. When the function is 1 to 1. When the function is 1 to 1, we want to know determine. When we say that the function is 1 to 1, the function has an inverse. We say inverse function. Remember, the inverse function only appears for the function is 1 to 1. If the function is not 1 to 1, that function has no inverse. Still is a function, but that function has no inverse. So in order to find that to find the inverse function, we have to determine first whether that function is 1 to 1 function or not 1 to 1 function. Okay, if the function is 1 to 1, then the function has inverse function. So the function has inverse function. So we need to determine to be the function has an inverse, the function must be 1 to 1. The function, it must be 1 to 1. Okay, let's say to determine the inverse function, let the function f(x) is square root of x minus 3. Find f inverse. Sketch the graph of f(x) and f inverse on same coordinates axis. And then state the domain and range of fx and state a range of inverse of fx. First, find the inverse function fx. To find the inverse function fx, we make y equal to fx. Y is square root of x minus 3. Or square root of x minus 3 equal to y. X minus 3 equal to y square. X equal to y square plus 3. That's the inverse function. That's inverse. So when we write x in terms of y, this is the inverse function. X square plus 3. The inverse is x square plus 3. We get this. Then sketch fx. Sketch fx. And in an inverse of fx on same coordinate plane. And now we sketch fx. What is fx? Fx is square root of x minus 3. Square root of x minus 3. So what is the square root of x minus 3? What is the shape of the graph? of the square root of function.
Dia lengkung ke kanan.
Right? Start from where?
0, 0.
0.
3.
3.
Why we start from 3? If you say start from 3, why start from 3? Yes.
Because if start from 0 is undefined.
Huh?
If start from 0 is undefined.
Start from 0 is undefined.
Therefore, start from point 30.
Okay, one reason. Another reason.
Shifting to right.
Shifting to the right. 3 units. The graph. This is the graph of the function x minus 3. Square root of x minus 3. Then the graph of the inverse. And the graph of the inverse of the function. Is the inverse of the function.
Square graph.
Square function graph. Okay, but is that open up, open down?
Open up.
Down.
Open up.
Open up. Why open up?
Because it's
X
positive.
positive.
Because x is positive. Remember the quadratic. When x is positive, the graph will be open up. But for the graph of the square function, here is 0.0. What in our case?
Shifting
Where?
to left.
In our case. What supposed to be here?
Shift to the left.
Shift upward.
Shift upward. Look back at the transformation. When you need to shift to left, when you need to shift to right. Remember that. Next week, we're going to have open book test number 1. So just 1 week. So remember that open book test number 1. Later, we'll focus on chapter 2. So you have to know where the time we have to shift to the left. Yes, shift to up. Shift to up. How many units?
3.
Shift to up. How many units?
3.
Units.
Three.
Therefore, must be stuck with 3 here. This. However, we have to look at the conditions. We have one condition here. Remember that. Domain of function equal to the range of inverse. range of inverse equal to, domain. Domain of inverse is the range of function. Now, what is the domain of the function? What is the domain of the function?
3 to infinity.
Sorry? What is the domain of the function? This function, this is the inverse of the function. What is the domain of the function?
3 to infinity.
3 to infinity. It is range of the inverse. So inverse must be 3 to infinity as well. So if you look at the graph, yes, it is from 3 to infinity, right? Domain of the inverse. What is domain of the inverse? Domain of the inverse, if you want to know the domain of the inverse, that's the range of the function. What is the range of the function? What is the range of the function? Range of this function, range.
Three until infinity.
Range. We talk about range.
0
0 to
3.
infinity. Therefore, range of the function, which is equal to the domain of the inverse, is from 0 to infinity. So, domain of the inverse must start from 0 to infinity. So, we have to remove this part. Why we need to remove? Because remember that domain of the inverse is the range of the function. So in order for us to know what is the domain of the inverse, look at what is the range of the function. Range of the function, 3 to infinity. That's domain of the inverse. We draw in the same coordinates plane. We draw on same coordinates plane. And if we look carefully at these two graphs, either for graph for the function and the graph for the inverse of the function, the graph of x squared plus 3, with provided that x is greater than 0, we can see that the graph, these two graphs is a reflections each other through line, the line y equal to x. So state what is the domain of the inverse. What is the domain of the inverse? What is the domain of the inverse? We talk about inverse. What is the domain of the inverse?
3 to infinity.
3 to infinity. And state the range of the inverse. What is the range of the inverse?
0 to infinity.
0 to infinity. No, domain of the inverse. What is the domain of the inverse? Domain of the inverse. Now we talk about the inverse. What is the domain?
Negative infinity.
0 to infinity.
Infinity. The range of the inverse?
3 to infinity.
3 to infinity.
Right. Any questions there? Yes.
So the function is not one-to-one function.
One-to-one function. This function is one-to-one function. We substitute one value, we got one value for another one. When we substitute A, we substitute A, we substitute B, same value. So when one-to-one, it has inverse. It's like this. One-to-one has an inverse.
Sir,
Yes.
for graphically method, what's the meaning of intercept at least at most one pointer?
Meaning that when you drag the line, it will always go intersect like this. You drag, uh, you drag, you drag the line, it will always have one intersection. So the graph or the function is one-to-one function. If you drag, you can see that more than one point, the graph is not one-to-one function. To know whether it is one-to-one or not one-to-one, we just drag that line. That's we call horizontal line test. let's say another function. Find f inverse first, find f inverse, and then sketch f and f inverse on same coordinates plane. After that, state the domain and range of the f inverse. So to find f inverse, y x minus 1 cube plus 2 x minus 1 cube equal to y minus 2 x minus 1 is cube root of f minus 2. When we want to remove cube on our left, we have to make cube root on our right. So x is cube root of y minus 2 plus 1. Cube root of y minus 2 plus 1. So the inverse function is cube root of x minus 2 plus 1. That's the cube inverse function for fx. And now sketch the functions of fx and inverse of fx on the same coordinates plane. The functions of fx is the functions of what? When we see that's x minus 1 cube plus 2
Cubic function.
cubic function cubic function, the shape is this. But now we have to shift to right 1 unit. And then we have to shift up 2 units. So the place 0, 0, points 0, 0, we'll go to the points 0, 1. And then we'll shift up 2. So we'll go to the points with the points of what?
1, 2.
1, 2. We'll go to the points 1, 2. So therefore, looks like this. Like this, right? Is the functions of x minus 1 cube plus 2. Then when we sketch the inverse function, cubic, x minus 2. So go to the right 2 units and then shift up 1. So what do we have? The shape will be what is the shape?
Like S. So,
Go the opposite way, right? It is.
yes, sir.
It's like that. Reflect about one line. Line y equal to x. let's say the function is the functions of x squared minus 3 for x greater than or equal to 0. Find f inverse and stick domain and range for the f inverse. So let y equal to x cubed minus 3. Sorry, x squared minus 3. X squared equal to y plus 3. X is plus minus square root of y plus 3. Since x is positive, so inverse of the function, we choose positive of square root of x plus 3. We don't choose a negative. If x is less than 0, maybe we choose, we're going to choose a negative. But because x is greater than 0, we choose positive instead of negative. Right. So sketch the graph of fx. The fx is the graph of x squared. The graph of x squared like this. But that graph goes down to 3 units. So it goes to minus 3 like this. However, the value of x only for positive. Therefore, we have to remove this part. So this is the graph of the function. What is our function? Our function is function of x squared minus 3. Provided that x is greater than or equal to 0. Then f inverse. F inverse is this graph. Graph of x plus 3. So the shape of the graph of x square root of x plus 3. What is the shape of the graph of the square root of x plus 3? The shape of the graph for the square root of x plus 3.
Curve graph.
The graph of the square root, but where it start? The shape of the square root, the graph is like this. Start at 0, but In our case, where it start?
-3.
-3. Why -3?
Because it's
Shift to
plus 3.
left.
Horizontal shift.
Because it shift to left. Ah. This is the inverse function. X plus 3. Right. When we look at these two graphs, it's like that they are reflections of about one line here. One line y equal to x. Line y equal to x. Remember that domain of function, range of inverse, range of function, domain of inverse. So what is the domain of the function? Domain of the function. This function, that is domain. This is the graph of the function. Black. Graph of the function.
0 to infinity.
0 to infinity. Therefore, that's the range of the inverse. So what is the range of the inverse? Is the domain 0 to infinity? 0 to the function. Domain for the function. Yes, 0 to infinity. So it's the range of the inverse. What is the range of the inverse? Also 0 to infinity. Yes, from 0 to infinity. Range. We talk about range. Range is what exists. Okay. Range of the function. What is the range of the function?
-3 to infinity.
-3 to infinity. That's the range of the function. Range of the function is domain of the inverse. Yeah, domain of the inverse start from -3 to infinity. Right. Hmm. Let's say the function is the functions of x square minus 2x minus 4, provided that x is greater than or equal to 1. Find f inverse. Sketch f and f inverse on the same coordinate plane. State range of the f inverse. Let y equal to x square minus 2x minus 4. Remember that x square minus 2x can be written as x minus 2 square. Oh, sorry, x minus 1 square. X minus 2, x square minus 2x minus 1. So it's minus 1. It's like that. Plus 1. So we want to make easier. We have the minus 1, then minus 4. We expect x minus square minus 2 is, and when we expect x minus 1 square, we're going to get x square minus 2x plus 1. That's why we want to make same back at my x square minus 2x without only 1. We have to minus with 1. So equal again. So it's like that y equal to x minus 1 square minus 5. It's like this. And now we search for inverse function. So we write x minus 1 square minus 5 equal to y. X minus 1 square equal to y plus 5. X minus 1 is square root of y plus 5. Plus minus. So x only is 1 plus minus square root of y plus 5. F inverse 1 plus square root of x plus 5. Why we choose plus, not minus? Because we have the condition that x is greater than 1. Now we sketch the functions of fx. Sketch the function. The functions of fx is the function of x squared minus x minus 1 squared minus 5. This is a function of fx. So it's quadratic, and we shift to the right 1 unit, and we shift down 5 units. So it does look like this. We start with 1 and 5 units down. Start here. This for the functions of f. fx is the functions of x minus 1 square minus 5. The inverse, square root of x plus 5. So we start where? We start at where? This is
-5.
-5. So square root, but we have to shift it up to 1 unit. It's like this. This is the graph of f inverse of x, which is 1 plus square root of x plus 5. So the place start here is point -5 for 1 for x and 1 for y. Because -5, 1. The place start here is 1 for x, because we shift it to the right 1 unit, and -5 for y, because shift down 5 unit. So when we look carefully, it's like that. Reflect about line y equal to x. About line y equal to x. Reflections about line y equal to x. Then find the domain and range domain of the inverse of function. You can see from here, what is the domain?
-5 until infinity.
Infinity. Range.
1 to infinity.
1 till infinity.
Sir,
Yes.
how you factorize to become x minus 1 squared minus 5?
Now you see the x squared minus 2x. We don't go to minus 4, right? We didn't go to minus 4. X squared minus 2x. So if x squared minus x minus 1 square, what we expect is going to be x squared minus 2x plus 1, right? So in order to remove that, we have to minus with 1. Why we choose x minus 1 square? Because we know that after expansion, we will get 2x minus 2x. If the number here is not minus 2x, we cannot use this. We know that because we know after we expand, we will get x squared minus 2x plus 1. But we only have x squared minus 2x only, not plus 1. So in order to do that, we have to minus with 1. Minus with 1. And we still have minus 4. So at the end, it's going to be x minus 1 minus 5. So with this form, x minus 1 square minus 5, it's easier for us to sketch the graph because we know that the shape of the graph will be the graph of quadratic. The graph of quadratic. Either open up or down, open up. The place of the start is minus 1, right? The place we shift. Remember that. Open up here, we shift 1 unit. And we shift down 5 units. And we use the transformation techniques to know where it's supposed to be start. Our graph originally like this, right? But we need to remove the left side because x is greater than 1. And then we have to move to right side because x is less than 1. X minus 1. Then we have to move down because minus 5. So at the end, the graph is like this. That is the graph of the functions. Then we want to find the graph of the inverse of the function. The graph of the inverse of function, we look at this. This is the shape of the square root function, square root of function, where it will stop at minus 5, but we need to move to 1 up. Let's say you have another function fx equal to x squared minus 4x plus 3, provided that x is greater than or equal to 2. Find f inverse, state the range of f inverse and sketch the graph of f inverse. Right. Yeah. you try that. You please you try. You're supposed to get F inverse is 2 plus square root of x plus 1. You're supposed to get this. This is an inverse, and also you state the domain, and then you sketch the graph. I try to do by yourself. So I think I'll stop here. Today you try to do yourself. You get this, and then you sketch the graph. You find the domain and range. Right. So please try to do yourself. Remember that our next, inshallah, we'll see you next tomorrow. 11 o'clock tomorrow. So with that, I close the session today with Tasbih Kifara and Surah Al-Asr.